Okay, so when doing this question, so that's the function. So usually when I do a question like this, I usually write down the function again. So usually I just go f of x equals x ln x squared. I should turn this down a bit. Even though it's pressure sensitive, it's a bit thick. Yeah, I might erase this. So yeah, so that's your function. The graph of the derivative is shown. It has a local maximum at point A, so you know that's a maximum, and a local minimum at point B, so you know that's the minimum. The derivative is given by this. But just remember that this function here is this function here, because it says the graph of this function, of the function, and a function. So it's like this is what it's talking about pretty much. So this one here, the f of x equals x l n x squared, and then x is greater than 0. This pretty much is because I don't think the derivative can go, I don't think the actual function can exceed this point because it's got an ln in it, but I'm not sure. So this is the function it's talking about though, right? Verify there is a stationary point at x equals 1. So you know that classic line, at stat point f dash x equals 0. So you know that you have fx here, but f dash x, but you don't need a derivative of it because you have it here. So f dash x equals 2 ln x plus ln x squared. And you can just make it equal 0. You can go set 0. So you'll have 0 equals 2 ln of x plus ln of x squared. And you know that it's at x equals 1. So I usually just do double arrow at x equals 1, comma. 0 equals 2 ln of 0 plus ln of 0 squared. Ln of, 1, not ln of 0. Ln of 1 plus ln of 1 squared. Now, according to, because, so with ln, so it's log base e of 1, so how you really, so usually when you turn this into like the notation of like exponentials, so this is the answer that you put in for this part, so, and this is your base, and usually when you do this, it gives you the answer. This is the same as this, but when you do e to the power of 0, it equals 1. That's the only thing you can do. So this log e to the 1 equals 0 here. So ln of 1 equals 0, so you can go 0 equals 2, 0, plus 0 squared, because these are the same, so it's both 0. 0 equals 0 plus 0, 0 equals 0. You go QED, it's a Latin thing that pretty much means I got the right answer. Or you can do lag, or you could do left-hand side equals right-hand side. They're both the ways that Miss said we can do it, but that's generally what you do for proofs. Okay, so determine the coordinates of A. A, you know, is here, but you're not going to use the graph to find it because the graph's a bit ambiguous, as you can see. Like, it's not really accurate. See how it's like slightly above that line, and like, yeah, it's an icky thing. So now determine the coordinates of A. So you know A is a turning point. You know it's a stationary point, right? Because stationary points are local maxes, max and mins, okay? Stationary points are local max and mins, because it's where it's the derivative is stationary, in case you didn't know. See, because the derivative right at the tip of that is stationary. It doesn't have a value. The gradient equals 0 at that point. That's why it's stationary point, you know? So, determine the coordinates of A. So you know that's a stationary point, so you use the exact same thing as before. At stat point, stationary is stat, f dash x equals 0. So now you have your function here, the f of x. So now go f dash x equals 2 ln x plus ln x squared. And then set to equal 0. 0 equals 2 ln of x plus ln of x squared. Now, So what you would do here is you can so you can put ln, because this is just addition, so you could just put this on this side and make it minus. So negative 2 ln of x equals ln of x squared. And now because there's an ln x on this side, ln x on this side, you can divide them both by ln x. And that will cancel this and cancel that, and these two will cancel. Negative 2 equals ln of x. Now, when you do this, when you have this part where you have ln of x and then a number, you can raise it by both to the power of e. I mean, yeah, raise both to be the eth power, because when you have, so let's say up here, you have log base anything, so a, and then let's say b. So this is your log. If you do a to the power of log a, b, this log a part and this a cancel, and it just brings this down. So you end up, which is with b, so this equals this, right? But because ln is equal to log base e, if you go e to the log base e, and then, what is it? So down here, it will equal x, so that would just give you e to the power of 2, negative 2 equals, and then they cancel, x. X equals e to the power of negative 2. Or x equals 1 over e squared. And the reason I do this double arrow kind of thing is I'm just showing, like, it's just continuation, I guess, because I don't want to go whoop. So yeah, just continuation. X equals 1 over e squared. Now, you can kind of prove this because e is around 3, because e is like 2.7, I think. 2.71 dot 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 dot. It goes on for a while. So that's around 3. So if you go 1 over 3, because it's 1 over e squared. So if you just assume that e is equal to 3, you can go 3 squared, and it's 1 over 9. It's something in there, you know, because this is like 0.5's like here. So yeah, it's around that. Okay, so you pretty much know that that's going to be a. Right, but then and now you can put this into let's just bring this out here. If you would, or on the exam, you just use the paper. So your x equals 1 over e squared. Now, because the points of a, because now we're found at the stationary point, right? But we want to know on this graph right here, this one here, we want to know on this graph, where is x, or what is the y of this? Because it's the coordinates, right? So if we go here, because this is the function of this, so we would put, so we'd go f of x equals, what is it? X ln x squared. And now we would just put this into it. F 1 over e squared, let's put that in brackets, is equal to 1 over e squared multiplied by ln 1 over e squared squared. Now, let's just make this go back to the other form, because this is equal to e to the negative 2 as well. So let's just put e to the negative 2 into here. So it's equal to e to the negative 2 multiplied by ln of e to the negative 2, and that in brackets squared. And now, you know, with ln, with any log, you can bring the power to the front and just multiply it. So that would equal to e to the negative 2, and then negative 2 ln of e squared, because you just bought this and put it in the front, and it ends up being that. Squared. Ln of the e, ln of e is equal to 1, so you can just cancel this, because this is equal to 1. So you'll end up with e to the negative 2 multiplied by negative 2 times 1 squared equals e to the negative 2, and then negative 2 squared. Negative 2 squared is equal to 4, so let's just put 4 there. So the coordinates of a, so this is the y, right? Because this is when you do f of x, so y equals 4e to the negative 2. So that means the coordinates will be the x, which was e to the negative 2, and then 4e to the negative 2. They are the coordinates of a. If you want to prove that using the second derivative test, you can. I don't know if you have to for this question, because it already gives you the x on the other one, x equals 1. So I don't know why they would make you use a second derivative test if there are 2 stationary points and it's already given you one of them. Like, wouldn't it just be the other, you know? So I don't know why they'd make you prove that, but maybe it's a part of the... I haven't looked at the marking guide. I don't really care. But that's really... this is the answer of the question. I couldn't figure it out in math because, yeah, I did something wrong in the working out, I think. Now this part, the graph of the function has the point of inflection at x equals e to the p. Point of inflection is different to a stationary point. Point of inflection, so at point of inflection, f double dash x equals 0. In this one, because it doesn't give you f double dash x, you need to figure that out. So it already gives you the first derivative, which is, if you take it from, I'm just reading it from up here, so f dash x equals 2 ln of x plus ln of x squared. Now let's get the derivative of this, alright? So, you need to, a derivative of f of x, so let's go f double dash x equals, now the derivative of ln x is 1 over x, you know that, so this is going to be equal to 2 times 1 over x, so 2 times 1 over x, because this bit here is this bit here, and I've just kept the 2, because 2 is a constant, so it's just going to be equal to 2 over x, because we're multiplying it, and then plus, and now this would use the chain rule, because it's to the power of 2, right, and it has a function in it. So you know that with chain rule, by inspection, you can do chain rule whatever way you'd like, but usually what I do for chain rule is I just bring this number to the front, do this function minus 1 on the thing, like a normal, so I'd go 2, bring 2 to the front, and then I would do this function, but this minus 1, so it would be ln of x to the 1, which is just ln of x, and then the derivative of the inside function, so 1 over x. This cancels because it's just to the 1, right? So you get 2 over x plus, and then I'm just going to put the 2 on here, so 2 over x ln of x, because they multiply. That's your function. F double dash x. And now let that equal 0. So 0 equals, because that you have to let the second derivative equal 0 to find the point of inflection, as you say up here. So 0 equals, and then it says there's a point of inflection at x equals e to the p. So then you can put that in as x, right? So 2, I'm just going to do the step first, plus 2 over x ln of x, and now let's let x equals e to the p. So now 0 equals 2 over e to the p plus 2 over e to the p ln of e to the p. Now one thing that you can do with this, because it has 2 over e to the p in both terms, is you can just take that out and put it at the front. So 2 over e to the p, and then everything in brackets, so there's just 1 here, because you've taken this out, so it equals 1. Because if you wanted to go back up to this way, right, 2 times e to the p times 1 would equal that. So then plus, and then you can take this out as well, because you've already taken it out to the front, and then it will just equal ln of e to the p. With your log laws, you can put the p to the front, right? So 0 equals 2 over e to the p, and then 1 plus p to the front, and then it will equal ln of e. When you take p out, right, let's just do the scenario here. P ln of e, once you take it out to the front, you can cancel the ln of e because it equals 1. So 1 plus p. And then you can make, so you can divide both sides by 2 over e to the p, because it gives you the two things, right? So let's just continue here. So this would cancel this would cancel, so 0 equals 1 plus p. And then, because you get rid of the brackets, right? Because they don't really matter at this point. 1 plus p, and then just put p on that side. I mean 1 on this side. So negative 1 equals p. There you are. That's the answer.